Okay, this is how the whole Floodknot is being tested right now. I have a sink or a tub that's connected to a washer and dryer hose. The washer and dryer hose connects to PVC pipe, which goes up past an outside pressure gauge, follows through the PVC pipe to the GC valve right there, and then from the GC valve I have a shutoff which I'm using to simulate a true shutoff. I have my sensor on the other side of that, so when this valve is closed, it's truly shut on the inside. This is the Honeywell 200 psi sensor. Comes down the PVC. I have an indoor or an inside pressure gauge. Comes down the PVC pipe, and at one point I had my spigot right here. That only gave me about 5 feet of PVC pipe to have water in it, so it was difficult to simulate. So I extended the PVC pipe, comes down, elbows, and I ran it into basically a 6 10-foot pipes. They elbow at the ends like so. Comes around. So basically, where I used to have 5 feet of pipe, I now have about 75 feet of pipe. At the very end, I come to my spigot, and this goes into my tub. So coming over here, the connection's coming off of the sensor right here. The sensor has, let's see if I can find this. Sensor has 3 wires that come off of it. It's got 2 black wires right here, which are basically ground and you don't use them. So I actually normally have those taped up. Then it has a red wire, and the red wire is the that would be the sensor positive on the board, which is difficult to see, but the red wire from the sensor goes into the sensor plus, and then the white wire coming off of the sensor goes into the sensor negative on the board. And then coming off of the GC valve there's 3 wires. There's a green wire. The green wire I have basically connected to my faucet as ground. I have it taped there. And then there's 2 black wires that come off of the sensor, and it really doesn't matter which one they go into. They both go into 24 minus on the board. They're both the same. So the system is mounted on the wall, goes through the piping. You can see the 60 feet of pipe. This is my testing environment. There's my spigot going into the tub. The hose coming off the sink. It's a little easier to see from here, and you got pictures of the dogs in the background. Anyway, coming into the computer, I have my board, which has the red wire from the sensor going into the sensor plus, the white wire going into sensor minus, and the 2 wires that come from the valve go into the 24 minus connections, which are the same. Then I have a power supply, which is a 24 VAC power supply. That's connected into the board. And then there is a, if you can see it right next to the chip here, there's a 6-pin ISP connector, which my video is poor, but you would connect it with this 6-pin ISP port here. So this wire connects into the pin by the 6-pin connector, which is right next to the chip. That goes into what they call an AVR Dragon. Atmel, the same company that makes the Atini chip, also makes the Atmel Dragon. This is basically a programmer and a debugger. It allows me to see the code as it occurs, or what to program it. That has a connector coming into here, which runs into an ISP connector coming into my computer. Now, I'll step through how the code actually works in a different video, but that's the connection to the computer. That's how the code gets from the computer to the through the AVR Dragon, connects to the board. That's how the board connects to the environment. And right now I have the board in override mode. So when I push this button here, which is the override button, it'll exit out and the valve just closed. If I push this button again, you hear the valve click. It's an override. It doesn't really matter what I do at this point. I can turn the water on. Nothing's going to occur because the valve is on. That's the first time I've ever put it on, actually. So I just re-PVC'd it a little while ago. So it's running right now. The valve's going to stay open basically because it's in override mode. If I were to wait an hour, that would shut off, and so wouldn't the water. If I were to push this button, the valve will close. You'll hear the water stop. And then, actually, now it's detecting demand, but we'll save that for another demonstration. But for now, that's my testing environment, and that's that.